One more unique feature associated with cradle was package weight compensation device. What is this package weight compensation device? The pressure between package and the drum influences package density. Higher pressure will create package with higher density and vice versa. And I told you earlier that you have to put dead weights here in order to adjust the pressure between drum and the package. Now please take note that as the package is filled more and more, there will be accumulation of yarn on the package, and weight of the yarn on the package will create additional pressure between the drum and the package. Now it is desirable that the package density should remain the same from beginning till end, but with growing package, the yarn weight will increase the pressure between the package and the drum, and what would happen because of that as the package is filled more and more, the pressure is increased. So what will happen is that as the package is filled, the package will tend to be denser. That is, it is softer inside and denser outside. Now, this is not desirable. So, a device was incorporated, that is package weight compensation device. This was a mechanical device. What this device consists of? Now this is the piston rod. Piston rod carries a plate. Here this is a lever, and this lever is applied with torque of a clock spring. So inside end of the clock spring is fixed and the outside end is connected to this lever. Now the spring tends to unwind this way. Because of that, this lever tries to move anti-clockwise. This lever carries a bow that pushes this plate upwards. Thus, the device here tries to create an upward force. So this force will decrease the pressure between the drum and the package. Now, as I told you that the growing weight of yarn on the package will tend to increase the pressure and thereby increase the package density. If we do not want this to happen, what should be done is that whatever additional pressure is created because of weight of the yarn, if I can create an equal and opposite force in the opposite direction on the cradle, then the pressure here can be kept the same and the variation in package density can be avoided. So as I told you here, this ball provides an upward force. So what is required here is that the upward force here should keep on increasing with increasing size of the package in such a way that the force created because of additional yarn in downward direction is counteracted by the force developed here. Now let me show you in this animation that what happens as the package increases in size. Actually the package would increase in size slowly, but here it is just shown in one step. So this is a package with smaller diameter. When the diameter increases, the situation is like this. Again you see. So what you notice here, that as the package grows in size, this rod will move upwards and this lever will turn in counterclockwise direction, and the coiling of the spring will reduce. So there are two things happening here when the package grows in size. The torque of the spring will reduce, but that reduction is very negligible because the angle through which this lever turns is very small. So spring torque almost can be considered as constant or with very little change in the spring torque. So again see, smaller dia, bigger diameter of the package. Again see, smaller diameter of the package, bigger diameter of the package. So try to see the change that is taking place here. Now let us try to focus here with an enlarged view. So observe again, smaller diameter, bigger diameter. Smaller diameter, bigger diameter. Now you take note here that the upward force applied here by this bow depends upon torque of the spring and is also depends upon the perpendicular distance, that is perpendicular distance between the bow and the center of this lever. So perpendicular distance here would be like this. So this is the perpendicular distance, this one. So what you notice that as the package becomes bigger, this distance decreases. So this distance decreases as the package grows in size. Again you take note of this. This perpendicular distance is larger, and as the package grows in size, this distance has become smaller. So if this spring torque is practically considered constant, then the upward force keeps on increasing as the package grows in size because of the decrease in the perpendicular distance. Thus, at smaller diameter of the package, the upward force is smaller, and at bigger diameter of the package, the force is increased. Thus, what the package weight compensation device does is that as the package grows in size and you are putting more weight of yarn on the package weight compensation device provides a counter force, and it can help you to maintain the same pressure between the drum and the package. That is the basic purpose of package weight compensation device. This clock spring also enabled the setting of the pressure. So the inside fixed end could be rotated through setting, and if the spring is wound more, the counter force will increase and the pressure will decrease. Thus, the amount of compensation could be adjusted, that I will show you in the photograph. So this was called as the control housing, and there was a setting here to adjust the spring torque, and it could be increased or decreased. So higher winding of the coils of the spring increases the counter force and vice versa. Thus, package weight compensation device is basically provided to maintain the constant pressure between package and the drum.